population size here. And right now it says it's a double by default. What should it really be? It should be an int. Because we're not in the habit of creating populations with half agents. And you might think that, because sometimes we have stocks that count the number of people in a population. They have 0.25 agents, but or 2.5 people in quantity. But here we actually want to keep track of the count in a quantized way of the number of people. Okay, so we're going to do it, and we are going to set it to a value of 100 as its default value. Okay. Now, this default value is used unless it's overridden by the enclosing object. So when I specified that default value within a person for the value of income, that would have been ignored if the population imposed a value on it, using a different expression. So this default value is only used if it's not told to assume a value by the next enclosing object. We're going to use a value of 100, okay? Default value 100. You notice that it's in a slightly different version. It's a different place in this version of AnyLogic, okay? So that's good. And then we are going to have the population size be determined by that parameter. How are we going to do that? So suppose we want our population, this population called population, if we want that size to depend on this population size, where would we specify that? Does anyone remember? Where did we specify the size of this population to use in the first place? Okay, it's in the properties for the population. And where is it here? Yeah, this thing right here. So we're going to go down there, and we're going to say population size. I'm going to do control space so it can fill it in for us. Boom. Okay. So now this is a assumption about the model as a whole, population size, that's going to dictate at an operational level the number of agents that are so-called replicated within our population. Okay. So we're going to go see how that works. Now, where is the value for this parameter, population size, specified? I've mentioned it before, but where is it specified? It's specified in, well, okay, the fact that there is a parameter, that parameter lives in main, but who tells it what to assume about that? That parameter is there. It says, hey, you can tell me some assumption about population size, and by default I'm going to assume 100, unless someone tells me. But this is remember, it's saying that I'm making an assumption about population size, and it's saying there's some way you can tell me what that is. Who tells main what to assume for it? Well, yeah, it's called simulation up there. It's the experiment. And in general, ladies and gentlemen, we will have multiple experiments, not just one. Here it's called simulation. But we're going to have multiple experiments. And they're going to each represent different scenarios. Different runs of the model that assume different parameter values. And that will yield, presumably, different emergent results, right? Okay, so we're going to go and we're going to go see how we can specify that, okay? So we already said, okay, the population, it has a size, population size. Let's go down to simulation, double click on simulation, and where would I go specify that? Where would I specify that parameter to main? Yeah, exactly. Yeah, sometimes my questions are pretty straightforward. So that's where it is. So when you add a parameter to main, it automatically adds a field for it here. And it puts the default value to use. It fills in that value. That's the default value you specified. So here, maybe we want to leave it as 100. But ladies and gentlemen, how would we create an alternative scenario which uses a different population size? Riddle me this. How do we specify it? So let's suppose, so for this experiment, we're assuming a population size of what? 100. Right. So now let's suppose we want a population size of 500. Where do we go specify? How do we do that? Let's suppose we want an alternative experiment where we do this. How would we do this operationally?
Create a new experiment.
So
New.
Right-click on the project, new, and we go to experiment. Exactly. We just want a standard simulation. We'll get into these in the appropriate lectures. We'll say big population, right? And we'll finish. I mean, not how I'd recommend documenting it normally, but that's adequate for our purposes. And then, in big population, we'll specify population size of 100, right? And now, if we go run big population, we should see something different. And it's doing this, and we may see a bit of a pause, but there we have, ladies and gentlemen, a bigger population. Okay, so let's be clear about this. We started with adding a parameter to the agent, which was, well, we had income already there. We did that last time at the close, and then we did sex, and the values for that were specified by main. But specified by main specific to a population, a collection of people, this population aggregate that was there. And then we added a parameter to main, and the person who tells main what to do, well, it's not a person, but sometimes we anthropomorphize things. The thing that tells main what to assume is the simulation, or the experiment, the scenario, as it were. And then we can go specify in that scenario what to assume for it. And that affords us the opportunity to specify different values. Now, let us now go address Todd's question. Show one way of doing Todd's question. Okay? So Todd's question was, how do we specify? Let's suppose we wanted one value drawn from a distribution that's used for all agents, the income of all agents. So that was one interpretation, right? Let's suppose we want agents to have a randomly drawn income, but we want it to be shared by all agents. Okay, so what would be one way of doing that? Can anyone think, using the mechanisms we just explored? Well, okay, here. What's that? Yeah, we have a parameter main, exactly. So we drag over from parameter, and we have, income. We can call it income here, right? And we're going to then use that income to set the income of each agent. So instead of having this expression, what am I just going to type here?
Or what about saying, having the average income vary and setting a normal distribution?
Great.
Is that okay?
Okay, I think Todd's question, though, so yes, you could do that. I mean, okay. So in other words, you could have a normal, so we could have a normal centered on this value here. You notice here there's a version of normal where you specify the sigma, and this is the mean, right? And so you could have some variation around that income. But I think Todd was wondering about if you could have one value for all of them. Yeah, you could have income here, and then that income could then be specified here by single draw from whatever, a normal distribution or a uniform distribution. And here, so I'm going to do, draw from a uniform distribution between 10,000 and 50,000. Now, but the semantics of this are very different. Before, I had income set between 0 a uniform distribution between 0 and 50,000, but it was different for every agent. Here, ladies and gentlemen, we're specifying a single value drawn from this distribution for the main, and the main passes that on to the population, to each member of the population, saying, assume this income, assume this income. And so here, if we run this model now, and we'll do it with a big population, okay? Boom. So here we have this. Evidently, we got a low value for the income because the values of the radiuses are small. And you recall we set it based on income last time. And if we go up, everyone has the same income. It's randomly drawn from between 10,000 and 50,000. It is just the same for everyone because there's one value passed in by the experiment that was then used for this parameter. So does that make sense? So that would be one fairly clean way to do it, actually.
So if you actually wanted to,
Yeah. Oh, go.
if you actually wanted to change the structure of it,
Yes.
if you had a global, that would just be different models.
So change the structure of the model. So like you wanted
So rather than
different state charts or
Well,
something.
no,
Right.
rather than having it specified in each variable, or in each agent,
Right.
if you wanted to pass that globally,
Oh, yes.
that would actually be a change the structure of the model.
Yes, and we'll in fact see models where that's exactly done. So in other words, if we had this situation where we knew for the purposes of our modeling that we don't need each agent to vary by income. We want to assume one uniform thing about them. You probably wouldn't put income as a parameter of the agent. Instead, what you would have is each agent ask main, say, hey, tell me what to assume for income, and it would tell it, and it would use that value. You wouldn't need to store it in each agent. We really only want to store those quantities for those agents which could plausibly vary between agents. Otherwise, you can kind of delegate it. Now, there's a proviso to that, which is for neatness reasons, we might want to associate with the agent class, even though it's not specific to each agent. We can do that through static variables. But I'm kind of getting ahead of myself in terms of presentation. So, okay. So, additional questions? So, yeah.
Yeah, I'm a little forming, but
Yeah.
I guess here's something that I would consider normally to be a programming protocol that seems to work out, which is that you have two parameters,
Yeah.
that's within the population and one that's within the main.
Yeah.
And yet it still works, right?
Oh, yeah.
So where does AnyLogic draw its line
Yeah.
that you can use the same
Okay.
variable?
So, this gets into a tutorial topic that I would like to cover in more depth at another time, but suffice it to say that we need to distinguish here between what's legal and what's desirable from a standpoint, a programming standpoint. When we're building programs, there's a lot of things that we can do, but we have to be cautious about doing because it can be confusing and it can lead to errors, right? It can lead to a greater amount of time to figure out what the model does, a greater amount of time to communicate to someone else, and a greater chance we'll get confused late at night and make a mistake, or take us a longer time to figure out the source of a problem. Right? What I've done here is to illustrate a point. It's a little bit of what goes by the technical term quick and dirty, but it is something which is taking advantage of an important principle here. So this income here, I could have given it a different name, like global income or income assumption, model income assumption or something like that that would have distinguished it from the level at the individual. But suffice it to say that the term income within the person class, it means a different. It refers to a different thing than income at the main level. I'm going to try to create an example of this. So you might have in your model two different types of class, a class for two different classes for different types of agents. So there might be, for example, a person agent, and there might be a deer agent, something along those lines, right? You might have a variable for each of them. In each case, there might be a variable that says, something in common. Maybe it's their age, for example, or their height. Let's suppose height, right? It's kind of a weird thing to imagine for a deer, but it might have a height. Now, height actually means something semantically different for a deer because the way we measure well, okay, I'm not an expert on deer, but the way we measure deer height, I think, is with respect to kind of the crown of the head, and yet, it's taken with both feet on the floor, right? With humans, normally we stand bipedally to measure this. We don't go down and measure the top of the crown of the head, and so there's kind of some different semantics, but we might want each of those classes to have a thing called height, right? And in general, Java will have no problems with that, because height in the context of deer will be referring to deer height, and height in the context of a person will be referring to person height. So we talk about the scope of a variable, and what the scope of the variable means sort of over what area of the program can you see that variable and interact with it. So if I have a variable called income within person here, main doesn't know particularly much about that variable. And if I actually referred to the name income in main, it would say, I don't know what you're talking about. I just don't know what's income. And there's a good reason for that, because I might have different, I might have a patient and a doctor, and each of them has incomes associated with them, and I wouldn't know, you mean patient income or doctor income or what? So in general, when we have one of these parameters, it has a scope. There's a set of things in the model that can see it and that can refer to it. Here, the scope of this income here is the main class. That's the only things that can kind of see the value of that. The scope of the income inside of person is the person class. That's the only things that can see that income. And the point of interface is when you create one of these people, you can specify, a value to use for its income. But, if I got rid of this income variable, as I'm going to right here, boom, gone. And I try to refer to income, as I do right at that point we're looking at, right at this point here. If I referred to income, and I tried to tell it, use income there, we could do model build. We'll attempt to say, check this model. Get this model ready to run. It will say, hey, income cannot be resolved. It doesn't know where to look for it. So in general, when we put some parameter within a certain class, main class, person class, the only things that can know about that, can refer to it directly, are within that class. Now, there is a way to kind of transcend that. There is a way to put what's called a qualified name that will let us refer to that variable, but I'm not going to present that right now, okay? That's something we'll build up to as we understand how Java expressions work, etc. Okay? Okay. Other question? Yeah.
I think the quick question is just in the example just now, if you have the same income for every agent,
Yeah.
actually you don't need to define the parameter income in the agent.
And that's what I was saying earlier. If you knew in your model that was to be assumed, that you don't need you don't need income heterogeneity in your model. You shouldn't, in general, there's no need to create that parameter in agent. Instead, each agent, to ask what to assume for income, it could just ask main, tell me what to assume for income, and main would say down to it, assume this, and it would then assume that. It doesn't need to store it within each agent. It doesn't need to keep it, carry it around with it, and so on. So It's a very good point, and it was that point I was trying to make. But you know, sometimes like you might want to temporarily just examine it, and then you want to go back to it. In which case, you might keep it around in person. Okay. Sorry, some of that has gone over people's heads. I'm trying to address people with different levels of background. Okay. So okay, we're going to go back and we're going to do the value here. So uniform, and we're going to do 10,000 to 50,000. Okay. By the way, you'll notice this little X here. That's what it put in when it couldn't find what income referred to what income referred. And that's a warning that it can't make progress without us resolving that. Now we've kind of fixed it, and we can actually tell it, hey, take into account my fix by doing a build. The build gets this ready to run. We're ready to roll. And now we can go and run this thing. We can right-click on this, and we can run, and it works with respect to this. Boom. Now we have a population that is indeed varying again. Okay, that's a glimpse of issues here. Any further questions about that before I go into variables? So variables are going to sound similar, but they're not used to communicate assumptions. Okay. Okay. Variables are particularly used for time-varying quantities within the model. They store information like parameters. Like parameters, they have a type, an integer, a double, Boolean, a color, you know, or a reference to a person. This can even be a variable. So could a parameter for that matter. But these are, variables are particularly well suited to time-varying quantities. And you'll notice that some variables, like